Everyone. All right, in this video, we're going to talk about winds and pressure systems. So we've been talking about pressure systems for a little bit now. We talked about the cans and the crushing. We talked about the syringes. What we're going to do now is start applying that knowledge to our atmosphere. So the whole goal of this presentation in this week's asynchronous lesson is to explain how winds are created and why different regions of the world experience different types of winds and weather. So that's the dream, right? That's where we're trying to go with this. Why do different areas have different weather and winds? And how does it actually affect them? That's like the big goal of the day. Old vocabulary that we're going to review real quick is pressure, force, composition, altitude, temperature, convection, and troposphere. Of course, yeah. Some new vocabulary that we're going to work on reviewing is low pressure areas, high pressure areas, and now instead of just talking about them in closed containers, we're going to be talking about them in our atmosphere. And then we're going to talk about land breezes and sea breezes. So we're going to be applying a lot of the information that you already know. So to start up, just a quick review. Pressure is the amount of force applied over a unit area. The amount of force applied over a unit area. This picture kind of depicts what's going on here. This person's pressing down, they're applying force on just like this little area. That's pressure, right? You're applying pressure to something. Now, if we're going to use that word force, we got to know exactly what that is. And force is a push or pull on something. So anytime you're pushing or pulling on something, that is considered a force. Another big vocabulary term in order for us to understand what pressure is we have to understand what composition is. And that's what something is made of. That's what composition is. Humans are made of cells. That is our composition. The air is made of 78% nitrogen and 20.9% oxygen. Thank goodness we needed to breathe. So this is an example of what composition is. Now, if you want to see it at the molecular level, when we talk about composition, we're literally saying what molecules are involved in the air. You can see molecules of nitrogen. We got some water in our atmosphere, oxygen, a little bit of argon. So again, composition is just what something is made of. Some other vocabulary terms we need to be aware of is altitude. Remember, altitude is the height above the ground. So it's above technically sea level. That is your altitude. So the higher the altitude, the higher above ground you are. Remember, we have lower pressure up there too, right? It gets a little bit colder, lower pressure, all that jazz. Temperature. Now, remember we were talking about it's not just how hot or cold something is. What exactly does that mean? Temperature is how fast particles are moving. So how much energy particles have, that is what we mean when we're talking about temperature. So low temperature particles are going to move a little slower. Whereas high temperature particles, they have enough energy to move moving further and further away from each other at faster rates. So temperature in this sense is going to be how fast those particles are moving away from each other. High energy particles are spreading apart from each other. Low energy particles are going to be a little bit closer together. So other things that we've covered so far, right? In our last unit, when we were talking about the layers of the earth, we talked about convection cells. So remember, convection is the transfer of energy through the movement of fluids. Back when we were looking at lava and how that worked, we got hot things blank because they are blank dense. Remember what hot things do? Think about it. Hot things, those particles get enough energy, they start to expand. So they rise because they're less dense. That's what hot things do. Because they're less dense, just like a hot air balloon. You turn that flame on, those particles heat up, they spread out, and they start to rise in the atmosphere. Now, cold things do the exact opposite. Instead of having our particles all spread out, they get closer and closer together. And that causes them to sink because they're more dense. And while we were talking about the layers of our atmosphere, we're talking in the asthenosphere, how we have lava rise to the earth, to the surface of the earth because it's less dense. And then that cold crust at the subduction zone dove under, it sank because it was more dense. The exact same thing happens in our atmosphere, where we have areas of hot and areas of cold, and that causes movement of not just rock in our earth, but in our atmosphere. It moves the air. So gas particles have enough energy to spread out, which causes a decrease in density. That's something to keep in mind. More energy equals lower density in an open system. We'll talk more about that on another slide. So how can we start applying this stuff to some of the activities that we did? So if you recall the syringe activity that we did, where we had our plunger, right? And we could smash that plunger closer that way. And we caused this high pressure area inside of our syringe. And it's a high pressure area because we have all these particles that are really stuck together. They're really close. And when we allowed our syringe to open, it caused the movement of air. And that's what wind is. Wind is just the movement of air, and it always moves from areas of high pressure to areas of low pressure, to areas of low pressure. Every time. If we have a high pressure area, remember the universe tries to seek out balance. So it's going to try to go from high to low, which is why wind came out of our syringes. Particles with high density is a high pressure.